All right, welcome to Mod 1, Lesson 11. Okay, today we're going to be looking at multiplying decimals by a whole number. Okay, now on our table of contents, we know this one here is multiplying decimals, and we're going to be using pictures, and we're going to be trying to relate it to a standard algorithm. Okay, in Lesson 11, our standard is still MAFS 5 MBT 27, and you can see the standard sheet in order to find out exactly what all that says, but the one skill we're looking for in the lesson objective for this one is we're going to multiply a decimal fraction by a single digit whole number and relate it to a written method through application of the area model and place value understanding and explained reasoning used. And our essential question, how can I use drawings and strategies based on place value to multiply decimals and relate the strategies to a written method? When we're saying related to a written method, we're pretty much talking about a standard algorithm. All right, so let's get started. Okay, so our first problem here, we have 3 times 2/10. And we're going to use a drawing and a place value in order to understand this. Now the first one we have 2/10. So I'm going to come up to the tenths and I'm going to put 2/10 in there. But our problem says 3 copies of 2/10. So 3 copies or 3 times 2/10 would look like this. So now when I added these up, I can see I would have 6/10 in total. And our answer would be 6/10. All right, let's try this again. This time it says 3 copies of 3/10. Okay, well there's 1, 2, 3. There's 1 copy, 2 copies of 3/10, 3 copies of 3/10. And we can say if we counted them up, we would have 9/10. So 3 times 3/10, or 3 copies of 3/10, equals 9/10. Now the next one is 4 copies of 3/10. So we're going to go ahead and do 4 copies of 3/10. Here's 1 copy, 2 copies, 3 copies, and 4 copies. And when we add this up, we got 3, 6, 9, 12, so we have 12/10. Now we know we cannot keep 2 digits in one place value. So this 10 here would have to go over to this one. And we can see this by we have 3, 6, 9, 10. So when we count that, that would end up being 1 whole. And we would have 2 remaining. So just like here, we end up 1 whole, 2/10 remaining. Our next one is 2 copies of 43/100. Now this was a little different, but not much. See, we have 2 place values now. We have tenths and hundredths. And I'm going to go ahead and put 1, 2, 3, 4 tenths here, and 1, 2, 3 tenths in the hundredths. But it's 2 copies. So I'm going to go 1, 2, 3, 4. That's 2 copies of 4 tenths and 2 copies of 3/100. And we add these up, I can see I have 6 hundredths and 8 tenths and 0 ones. Now we have 3 place values, tenths, hundredths, and thousands. So we're going to do the same thing. We're going to put 4 tenths in here. I'm going to put 2 hundredths and 3 thousandths. But it says 2 copies, so I'm going to make 2 copies of that. So now when I add this up, I can see I have 6 tenths, I have 4 hundredths, and I have 8 tenths. So our answer is 846 thousandths. Okay, let's do one more. This one has 4 copies of 4 times 423 thousandths. So we're going to go ahead and put our 4 tenths in. We're going to put our 2 hundredths and our 3 thousandths. But we're going to do 4 copies of that. And our 4th copy, Now, first off, I'm going to add these up. And there's 3, 6, 9, 12. So we have 12 here. Now what that tells me is that I have 10 of them here. 3, 6, 9, 10. And that's going to have to regroup over here to one whole. So our 2/10 would remain in this column, and our 1 would be taken to the next column. Now we count up the next column. Here we have 3, 4, 5, 6, 7, 8, 9. So we have 9 hundredths. And on this one I have 4, 8, 12, 16. But once again, there's 8, 10 right here. And that would come over, make one whole. And that would look the same as this one being brought over to here. And you can see we still have 6/10 here. So our answer is 1 692 thousandths. Okay, so this was a way of doing it with using drawings. Now let's see, what if we used an area model? Okay, for this problem, I'm going to put the whole number, 6, on the side, and I'm going with 1, 1. Then I have 2/10 and 1/100th. Now this one's going to be 6 times 1, 1, which is going to give us 6 ones. This is 6 times 2/10, which is going to give us 12/10. I got to write the ones in there. And the last one over here becomes 6 times 100th, which gives us 600th. So I can see this 6 stays here. Now the 12/10, this 10/10 is going to have to become, regroup over here, it's going to become 1, 1. So now we know we have 2/10 remaining. And then we put our decimal point in. And here I have 6 and 1 is 7 ones. So this would equal 7 26 hundredths. Now let's see if we can do this with a standard algorithm. Here's 1 21 hundredths. And we're going to multiply this by 6. Now I know you're saying, I've never multiplied a decimal before. Well, we're going to ignore the decimal. We're going to multiply this just like the decimal was in there. So here I got 6 times 1 would be 6. 6 times 2 would be 12, and I carry my 1. 6 times 1 would be 6, and 1 would be 7. But now I've got 726. Well, the easiest way to find out where to reasonably place this decimal is to do an estimation. This 1 21 hundredths, is that closer to 1 or 2? You should say 1. So 1 times 6 would be 6. So in order to put this decimal reasonably in here, we would put it here, which would be close to 6. Our next one, we're going to put 7 here, 2 ones, 4 hundredths, excuse me, not hundredths, that's tenths, 4/10, 100th. So now over here we got 7 times 2 ones, which is going to give us 14 ones. Here I've got 7 times 4/10, which is going to give me 28/10. And the last one is 7 times 100th, which is going to give me 700th. So the 7 can stay. Now the 28/10, we know we got 20/10 right here. And that's going to come over here and become 2 ones. And we have our 8/10 remaining. We add this up, we got 16 ones. Well, we know this 110 is going to have to come over here as a 10, leaving us our 6 ones. So we end up 16 and 87 hundredths. Now, once again, let's do this with a standard algorithm. And we're going to multiply by 7. 7 times 1 first gives us 7. 7 times 4 gives us 28. We carry our 2. 7 times 2 is 14, and 2 is 16. Now, we're going to estimate. Is 2 and 41 hundredths closer to 2 or 3? Well, it's closer to 2. So times 7, that means our answer should be close to 14. In order to get it close to 14, the decimal place would be placed there. Once again, whole number on the side. We're going 2 ones, 3 tenths, and 4 hundredths. Now we know this becomes 8 times 4 hundredths, which is going to give us 32 hundredths. And here we're going to have 8 times 3 tenths, which is going to give us 24 tenths. Our last one's 8 times 2 ones. This is going to give us 16 ones. Now, doing our regrouping, we know these 30 hundredths is going to become 3 tenths. That leaves us our 2 hundredths. Now, our 24 tenths and 3 tenths is going to give us 27 tenths, which we know the 2 is going to have to be regrouped as 2 ones. And we know our decimals right here because of the ones. And this is going to become 18 ones. Well, we know this 10 ones is going to become 110. So now we can see our answer would be 18 and 72 hundredths. Now let's see if we can do this as a standard algorithm. I'm going to put 2 and 34 hundredths, and I'm going to multiply it by 8. Now I'm going to ignore this decimal for right now, and I'm saying 8 times 4 is 32. I have to carry my 3. 8 times 3 is 24, and 3 is 27. Carry the 2. 8 times 2 is 16, and 2 is 18. Now comes, where do I put that decimal? Well, the easiest way to find this is I'm going to round this 2 and 34 hundredths to a whole number. Is that closer to 2 or 3? You should say 2. So 2 times 8 equals 16. So I know the most reasonable place to put the decimal would be here to make it close to 16. All right, I hope multiplying decimals didn't seem that hard to you. We do have to know how to do it with models. So I've shown you 2 different models. Showed you using the place value chart and using dots. And I've also showed you using the area model. And the last thing we did is we went ahead and used a standard algorithm, but then we used estimation in order to place the decimal point. Okay? All right, see you in class.